Hello. So this is the first time I've done this, so there you go. I want to get at least one high so people knew that I was here. So my name is Rene Simon. I'm a senior data scientist at Netflix, and I'm here to talk to you today about data science and how it can do some pretty amazing stuff. So we have about 20 minutes together. I'll take about 10 minutes to go over the presentation, and then hopefully we'll get a good solid 10 minutes at the end where you guys get an opportunity to ask as many questions as you can. So we'll go ahead and get started. So have you ever wondered how Netflix knows exactly which movies you like? Or how your credit card company knows when a purchase was not made by you? Or how Pinterest has honed in on your exact perfect clothing type and sense of style? The truth is that data scientists were born with a genetic mutation that allows us to see all possible future events, and we use this power to work for San Francisco-based companies. No, not quite. The real truth is we use existing data that companies have already gathered over time, and we use that data to build a model. And we use that model to make a prediction. Now, that prediction could be a sports prediction. That prediction could be, what movie you want to watch. And it could be a movie that you didn't even know existed. But based off the information we've gathered with people that behave like you and have your taste, we're able to figure that out. It could even predict what kind of music you'll like as an adult based upon your musical taste as a child. So how exactly does all of this work? How do we go about making all of these predictions? So it all starts with information. So let's take this completely not made up example. So we have a bunch of names, and we have their favorite food and their favorite sport, right? So if I was to say that my favorite food is spaghetti, what would you guess my favorite sport is? And you go ahead and put your answer in the chat. And this is if my favorite food was spaghetti. There you go, YJ, soccer, right? Now, of course, this is an overly simplified example. Everyone that likes steak likes football. Everyone that likes ice cream likes ice skating. And then spaghetti is soccer. But that's where it kind of starts. It's all about taking historical information and looking for patterns that existed in the past, and then using that historical information and patterns to make predictions in the future. So let's take a look at a little more realistic example. So this is some US sporting data, specifically height and weight. And it's a map of a lot of athletes, and they either play in the NHL, Major League Baseball, NBA, or the NFL. So what interesting things do you notice when you look at this data? Feel free to type in. What do you see? So what you begin to notice after a while is you see that a lot of the similar athletes are kind of clustered together in certain sections on the graph. So if you look at all the greens for NHL, they're all clustered in the right. And the y-axis or the x-axis is for heavier weight. So heavier athletes are with the NFL. Or the orange dots are further north on the graph. And that's along the y-axis, which is for the taller athletes, right? And then somewhere in the bottom left, you see some NHL and some baseball players that still have some separation based upon weight, but relatively about the same height. So this is a more realistic data set. And as data scientists, we try to gain insight into this information. And on a side note, I think my heavy weight means that I would be a football player. I'm not sure what other attributes are needed, though. So now that, what do we use this information for? Well, once we have this information, we use it to build a model. So if you don't understand coding very much, this is fairly readable. But the first question that one of you guys may be thinking is, hey, Rene, that's not a model. You didn't use any super fancy programming or really cool data sciencey techniques. Well, you're right, I didn't. But does that make it any less of a model? This is a simple function which takes in height and weight. And if the height is above 80 inches, we say, hey, you're a basketball player. If the weight's above 280 pounds, we say you're a football player. If the height and weight are in a certain range, but below 220 pounds, we say hockey. If it's a different range and between 230 and 250, we say baseball. But then there's lots of areas where it was too close to call. So I just returned some other sport for everything else. And so that's what I did, right? I just made general cutoffs above 80 basketball, above 280 pounds football. But is this a model is the first question. So do you think this is a model? And feel free to put your answers in chat. So I would say it is a model. Was it very difficult to make? Like, did I need, a bachelor's degree and a master's degree to kind of make the model that I just made? I would actually say no, because it is a model. However, I didn't use any special techniques. I just visually observed the data and chose certain cutoffs. And based upon those cutoffs, I said, well, if it's more than this, let's call it a basketball player. If it's a heavier weight than this, let's call it a football player. So it is a model, but it wasn't very difficult. So last question, is what I just did data science? And you can feel free to put your answer in the chat. So I don't think it's data science. I used some general ideas and general knowledge about the information, but not yet. I see a lot of people saying yes, and it was cool. I got a model that can answer something, but it's not data science yet. So what makes it data science? Why do data science get paid the big bucks? Why are we so valuable? Why are we in such high demand, right? And the answer is because we're not satisfied with a poor model. If we look at this model, there was lots of areas where, let's say your height was 79 inches. Well, that was between the 80 and the 78 on my logic. So therefore I wouldn't predict anything. So we take a look at that poor model and we say, no, we don't like that. We want a better model. So how do we go about making a better model, right? We want a model that answers all of the edge cases, all those borderlines between information. We want that. We want to strive for better accuracy and better precision. And when our models don't perform well, we take it personally because they're our babies. So how do we go about making our models better? What are some of the things that we can do? Well, we can research other data sources and look for items that could help us predict. Maybe in this case, we could gather the athlete's country of origin, their race or ethnicity, their socioeconomic status, what schools they went to. And all of that is additional information that may help give us a more accurate view, an accurate result. So we do a lot of research. And then the next thing we do is once we find all these additional data sources, we merge them together. We take all these, data sources about where they're born, how old they are, what they did in college, whatever other information we could find, and we put them together into one macro data set. And then we recreate our model. Now, the model I did was a simple, it was coding, but it was just a simple if-then loop. These models are algorithmic and are much more complex in nature. But we recreate the model based upon the additional information that we included. And to do this, It takes a couple different core areas. You need to have a good foundation in mathematics and statistics. You need to know your computer programming fairly well. And the last and most important and very often overlooked piece is you have to have some business domain knowledge. If you just have math and statistics and computer science, you're a machine learning person. But to truly derive insight out of your information, that's what you need the domain knowledge for, the business knowledge. So let's say I want to make a machine learning model in the medical field, then I need to do have a lot of conversations with doctors and nurses and learn about the medical field before I try to make a model to make some decision. But if you have the combination of those three elements, then you have what it takes to be a successful data scientist. So hopefully this did a good job of kind of shedding some light on exactly what it is that a data scientist does or how we work. I know the age group I was kind of gearing towards was K through 8, so that's a difficult range to span. But we've got about 9 minutes left, so feel free to ask as many questions as you can, and I will do my best to answer those. So one question was, what do I plan to do in the future? There's a particular area of data science which is called natural language processing, and another one is semantic analytics. And that is the idea of extracting meaning out of text. So you know how when you are texting on your iPhone, it seems to know what you want to say next. And the world is getting better at extracting true meaning out of text. And I think that's an interesting field that has a lot of area to grow. Someone asked, what specific department do I work for at Netflix? I am in the security group. So I work on fraud. Most currently, I'm working with a team called Customer Trust. And we try to detect accounts that have been taken over. So people steal your Netflix credentials, and then they take your account, and they could try to sell that account for a lower cost, or they try to sell use of that account so other people can share it. So we try to detect accounts that have been taken over. Let's say you're someone that doesn't watch Netflix very often. Your account may be taken over, and you may not know it at all. So there's not really a disadvantage to Netflix if an account is stolen, because the person is still paying for it. But what we don't like about that is that there's people out there doing bad things with our products. So we don't like that to happen. So we try to minimize any type of fraud that occurs on our platform. So in general, I work in security and fraud, but more specifically, I'm currently working on account takeovers. Can you give us some examples of how Netflix uses data science? Sure. So when we call them bad actors, when they try to take over an account, they try to do so via a variety of means. And we collect an awful lot of data at Netflix. So using all those data, such as the IP address that they attempt to log in from, the geolocation they attempt to log in from, the types of device that they attempt to log in from, we fraudsters have very specific fingerprints, and we have done a pretty good job identifying what those fingerprints look like. So I named a couple of them, but there's also a lot more factors that I don't want to get into too much detail with, in case there's a bad actor somewhere in this group. But we use all that information to kind of identify the behaviors based upon accounts that have been taken over in the past. And then we use that information to identify if we believe that an attempted account takeover is happening, and then we stop it from happening. What job do you have other than being a data scientist? Well, something else I do is I also teach a data science boot camp. I've taught that boot camp at Georgia Tech, and most recently I taught that boot camp at Norfolk State University. And I really enjoy teaching people about data scientists and help them on their path to become a data scientist. I think the world needs a lot more of us. I think we are very able to help businesses do well and do better with the resources they have. And in general, I like to help people. So the other thing I do is teach. Are people who share their Netflix passwords with friends and family considered fraudsters? No, you're absolutely not considered fraudsters. We do categorize that as a multi-home users, and we try to keep track of how many accounts are being shared. And we have a variety of ways that we do that. And right now it's okay. But as we continue to grow, we want to do a better job of tracking who's using Netflix. So if Netflix is too expensive, then maybe we think of altering the price a little bit to make sure that each person has their own account and password. But right now we simply track it. It is not considered a bad actor. And yes, go Jackets. What else do we have? What other job options did you consider? Previous to being a data scientist, I was a programmer. I was a production support manager. So I've held a lot of different roles in IT. And then most recently, I received my MBA from tech. So I think the benefit of that is all that different information allows me to better solve problems. Because in the end, what a data scientist is quite simply a problem solver. And we use many different tools in order to solve those problems. I think that's most of the questions. Did you have to work at a different company before you started working at Netflix? I worked at many companies. Prior to Netflix, I worked at a company called Airbnb. You may have heard of them. Prior to Airbnb, I was a consultant. That means that I worked for one particular company, but I solved problems at many other companies. Prior to that, I worked at Verizon. I've also worked at First Data, which is now Fiserv, PricewaterhouseCoopers. Somebody asked, what was my hardest data problem? I had a very difficult problem that I worked with Cox Communications. They are a cable company in the Atlanta area. And they were trying to solve a problem where when technicians come out to your house, they want to know approximately how long that job will take based upon the type of work it is. And they were very inaccurate previously. They based it off the kind of job they were doing. But when I went there, remember in the presentation we talked about find other information and you join it. I joined information with the time of day, the weather, and I even connected to a Zillow API to attempt to find out information about the house, how old the house was, what kind of build it was, how many bedrooms it had. And with all that information, we were able to give a much more accurate time regarding how long the technician should take at your job, which helped this cable company with their technician scheduling. And yes, math was one of my favorite subjects, more specifically geometry, but you do have to have a pretty good math background to be a data scientist. And what sort of prior experience do you need in order to become a data scientist? What sorts of degrees will you need? Personally, I have a computer engineering degree and then a master's in engineering and then MBA. But I've seen data scientists come from many, many backgrounds. The only requirement is a foundation in math and statistics and some computer programming knowledge. But I've seen people come from economics backgrounds, liberal arts backgrounds, medical backgrounds, law degrees, because lawyers have very good logic solving ability. So no particular degree is needed if you are able to self-study and learn computer programming on your own. But if you are going to college to become a data scientist, then I would probably lean towards computer science or computer engineering, as that degree will help you with your math and your computer programming at the same time. I think we have about 1 more minute if anyone has any additional questions. Well, I hope you guys I hope you learned something from this talk today. I have my Netflix email and my LinkedIn profile there. So feel free to reach out to me. If you have any additional questions, I'm more than happy to help. So I hope you guys have a wonderful day. Thank you all.